Hey everyone, welcome to today's lesson. It's Ms. Passmore here. Please get your materials ready because we will be taking notes and we will be submitting them for points today on Canvas. So you're going to need your iPad and open up to OneNote where I've downloaded today's notes for you, or you can use a different app, or you can use good old pen and paper. You're going to need something to write with like your Apple Pencil or pen and pencil. Your factor chart is going to come in extra handy today, and if you need it, you're always welcome to use a calculator. Go ahead and get those items, and while you're doing that, I'm going to tell you what we're doing today. Today, we're beginning our journey learning how to factor quadratic expressions using the Xbox method. Remember, with today's video, you can pause, you can rewind, you can speed up if I'm talking too slow, you can slow down if I'm talking too fast. Whatever you need to get this learning done, please go ahead and do so on our video. But remember, I'm not saying that we're going to be experts at it. We are just learning. We're beginning our learning on how to factor using what I like to call the Xbox. So without further ado, let's jump right into it. You'll notice that I gave you guys a factor chart to start in case you can't find your orange and pink paper. So it's always going to be like here, you're going to be able to use this. However, it's just kind of nice to have it off to the side to refer to quickly instead of having to scroll back and forth within your notes. But yesterday we left off with this challenge, and some of us got to the X game, which is essentially just this with an X. So I started off with like a puzzle, like, hey, I'm thinking about two numbers that are factors of 30, meaning two numbers that multiply to give me 30, but their sum is 11. They add to 11. So it was like, okay, what are those two numbers going to be? And really, you could have just used your factor chart and looked at 30, right? 30, we've got 1 times 30, that's a factor pair. 2 times 15, those are factors. 3 times 10, that's a factor. And 5 times 6. So I'm saying out of these factors, which of them add up to 11? Which of these add up and answer my riddle where their sum is 11? And that is only 5 and 6, right? So 5 and 6. Then I was like, okay, I'm thinking of two numbers where they multiply to give me 76, but they add up to give me 23, right? So what are these numbers going to be? They multiply to give me 76, so we're looking here, but they add up to give me 23. That's going to be 4 and 19, because 4 plus 19 is 23, right? So we did a bunch of these. We said, what are numbers that multiply to 8 and they add up to -6? And that was a bit of a challenge because remember that numbers that multiply to 8 are 1 and 8. Oops. 2 and 4. But also if I need negative numbers, that could be -1 times -8 and -2 times -4. That's why we ended up picking these two, because these add to give us -6. Same thing with numbers that multiply to 36 but add to 15. 3 and 12, it works for us. 180 was a bit of a challenge. We had to either think about like 18 and 10 multiplies to give us that, and if I add them, those aren't quite 27. But also, remember that factors are defined as numbers that multiply together, or you can find out if something is a factor of another if it divides evenly with 0 remainder. So I did a little bit of guess and check. I said 180 divided by 15, and I got out 12. That means 15 times 12, those two numbers were factors of 180. And what do you know? When I added them up, I got 27. What? The last one was a little tricky. Whenever you have a negative number, factors of -84, that just means either the first number is negative or the second number is negative. So you could look in your chart at 84. I was like, okay, 1 times 84. So it could be -1 times +84 or +1 times -84, right? And I'm talking about this part. over here. And then I was like, oh, those are way too far away. I need them to add up to 5. So I kept looking in that list, and I was like, you know what's 5 spaces apart? 7 and 12. So then I was like, okay, it's either going to be -7 and +12, or +7 and -12. And just by a little bit of checking, I was like, -7 plus 12, that adds up to 5. So this challenge right here is essentially the X game without the X, okay? The X game is a game I invented. Well, I didn't really invent it, but a game that I use to help us organize our factors. So for the X game, I'm thinking of 2 numbers that multiply to the top, but add to the bottom. Okay, just like it was here. 2 numbers that multiply to 36 but add to 15. Same idea. And so you can think of your factor chart, or you can think of this just with your brain, right? 2 numbers that multiply to give me 10, but they add up to 7. Well, 5 times 2, that multiplies to give me 10, but 5 plus 2, that adds to give me 7. And so those are my 2 numbers. Same thing. What is something that multiplies to 12 but adds to 7? Well, you could think 1 and 12, 2 and 6, but 3 and 4 is going to be better, because 3 times 4 gives me 12, but 3 plus 4 gives me that 7. Okay, what are 2 numbers that multiply to give me -24, but adds up to +5? Okay, so maybe you need to do a little thinking on this one. 24. One of the numbers is going to need to be negative. We have 1 and 24. We have 2 and 12. We have 3, 6, 9, 12, 15, 18, 21, 24. Yeah, 3 and 8. We have 4, 8, 12, 16, 20, 4 and 6. These are all the factors, and they can either be -1 times 24, -2 times 12, -3 times 8, -4 times 6, or 1 times -24, 2 times -12, 3 times -8, 4 times -6. These are the ones we want to check. I want them to add up to be +5. Looking at these, -3 plus 8, that's giving me 5. So my numbers are -3 and 8. It's not this one, because that's -5. And that's not what I needed. Okay, here's the next game. I want you to pause the video. I want you to try to come up with the 2 numbers and place them in the X that multiplies to the top value, but it adds to give you the bottom. When we come back, let's see if we're right. Okay, let's see if we got these values right. Okay, so I need 2 numbers that multiply to give me -18, but they add up to give me -3. 18 has factors of 118, 2, 9, 3, 6. I'm going to be dealing with 3 and 6. Why? Because those are 3 spaces away. But one of them needs to be negative, and it's going to be this one. Okay, 2 numbers that multiply to give me 90, but they add up to -19. 9 and 10 are numbers that multiply to give me 90, but when I add them, it's +19. So if I make them both negative, that still multiplies to give me +90. However, it does add to give me -19. Amazing. 28. I need 2 numbers that multiply to 28, but those numbers add up to -11. All right, this one's a little tricky too. 28 has factors. 1 and 28, 2 and 14, 4 and 7. 4 and 7 can give us 11. Oh, but one of them needs to be negative, right? I can't, 4 times -7 is -28. That's not going to work for us, right? So 4 and 7 is out. What about 2 and 14. Negative 14, 13, 12. No, it's negative 12. That's not going to work either. Sometimes you got to play the guess and check game. 28, 2 and 14, that's 12. 7, 8, 9, 10, 11, but that's positive. And then 1 and 28, that's not the one. Maybe I wrote it down incorrectly? Nope, 28 and negative 11. Wait, let me think on this. It's got to be, okay, let me just write it out. Sometimes when you're second guessing yourself, it's always good to write it out. Factors of 28, 1 and 28, 2 and 14, 4 and 7. Oh, you know what? I'm being kind of silly. If it multiplies to 28, they could be 2 positive numbers or 2 negative numbers. That's what it is. So I need the 2 negatives. I need negative 4 and negative 7. That multiplies to give me positive 28. But negative 4 plus negative 7, that's negative 11. I don't know why I was second guessing myself. But hey, just goes to show that you can second guess yourself and then check your work and you'll be all right. It's one of those things. So now that we've got the X game down, we are ready for Xbox, okay? And I don't mean like to bust out an Xbox and play video games, although that would be super duper cool. Xbox is something that is a nice organizational tool to help us factor, right? So what we've been doing is we've been doing a bunch of skills that are helping us factoring actually already and getting comfortable. The Xbox itself doesn't actually do the factoring, but it's just a really cool way for us to organize our thoughts. So we're going to use the X game and the GCF boxes to help us factor the equations. If you remember from yesterday, we used the box to help us extract the greatest common factor vertically and horizontally from our expression. So we're going to use the X that we just practiced and the box to help us factor an equation that's in this form, ax squared plus bx plus c, typically, but it doesn't always have to be in this form, but it should be close. It should be quadratic because the degree 2. And we're going to ask ourselves a series of questions. Number 1, is a negative? If it is, we're going to take out a negative GCF. Just trust me on this, okay? We're also going to look and see if there's a GCF. GCF is a really, really important topic, and if there's a greatest common factor between like A, B, and C, we should take it out immediately. It just makes our lives a little bit easier, the numbers easier to work with. Then we're going to identify A, B, and C, and we're going to set up our X, which is A times C, and B, again, what multiplies to the top but adds to the bottom. And what we do with that is we write those numbers over here in the X, right? Then we're going to fill in the box. Notice that ax squared, whatever this part of the equation is, goes in the top left, and the last part of the equation goes in the last box at the bottom right. What we do from here is we're going to fill in the boxes with the numbers from the X. Then we're ready to extract the greatest common factors. When we do that, we'll write them up here and over here, and finally, we'll write stuff in factored form with the stuff from the outside. So this is kind of the vibe that we're going with. So let's just get into an actual example so you can see exactly what I'm talking about. So let's use the X game and GCF boxes to help us factor equations like 2x squared plus 7x plus 3. This is my equation that we're working with, 2x squared plus 7x plus 3. So question number 1, is x negative? No. If it was, we would factor out a negative GCF. Is there a GCF between 2, 7, and 3? 2 is just 1 and 2, 7 is 1 and 7, 3 is 1 and 3. Nope, there's no GCF. We could say 1, but we don't really. That's not very helpful. So A is 2, B is 7, and C is 3. So far, nothing crazy. Simply identifying pieces. Now we need to fill in the top of our x. Our x is going to be 2 times 3. Sorry, the top of the x is 2 times 3. A times C. 2 times 3 is 6. So I'm looking for a number that two numbers that multiply to 6, but adds to B, right? Adds up to 7. So again, it's that same x game we were playing. Two numbers that multiply to 6 but add to 7, that's going to be 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. Okay, you'll notice that our box is already pre-filled in. I put 2x squared in the first box, 3 in the last box. That's going to be a standard setup. And the next thing we're going to do is we're going to take 6 and put it here and tack on an x with it. And the 1, put it in here and tack on the x. And now that we have our box filled in, we are ready to find the GCF. So again, remember we go vertically and then horizontally. So what is the greatest common factor between 2x squared and 6x? Well, they definitely share an x together, and 2 and 6 have a greatest common factor of 2. Then we'll do the next one. What is the greatest common factor between 1x and 3? Well, here it's just 1, and that's okay. Then we move horizontally. What is the greatest common factor between 2x squared and 1x? Well, they just share an x. And then the greatest common factor between 6x and 3. They share a 3. Just like we were doing yesterday, always go back and double check your work. When you multiply these things together, x times 2x does give me 2x squared. X times 1 gives me 1x. 3 times 2x gives me 6x. 3 times 1 gives me 3. Always make sure that that's correct. If it's not, then you might have missed a greatest common factor. And lastly, we're ready to put it in factored form. So my expression, 2x squared plus 7x plus 3, can be factored into x. Since 3 was positive, we're going to put a plus 3 and 2x plus 1 because that 1 is positive. Boom. What we just did is we factored our green expression that we started out with, and we put it in factored form, something that multiplies to give that result. Pretty cool, huh? You might be feeling a little overwhelmed. So remember, you can rewind if you need to. But I think after several examples, you'll start to pick up what I'm putting down. So let's use repetition to our advantage, shall we? I can use repetition and repeated reasoning to help me figure out this puzzle. So let's go to our next example. Use the X game and GCF boxes to help us factor the quadratic equation 2x squared plus 6x minus 20. Question number 1. Is A negative? No, it's not. If it was, we would factor out a negative 1 as our GCF. Is there a GCF between 2x squared, 6x, and 20? Yes, there is. There's a greatest common factor of 2. So pay close attention alert. You're going to take out a 2 immediately, and our new expression is x squared plus 2 times 3 gives me 6x, so 3x minus 10. This is what we're going to use for A. A is 1, B is 3, C is negative 10, okay? Super important that you're using these, if there's a GCF, those values to help you, okay? Otherwise, you're going to end up getting something incorrect. Now we're ready to use this information to fill out our X. I need a number that multiplies to 1 times negative 10, so negative 10, but adds up to 3. Okay, what are some numbers that multiply to negative 10, but adds up to 3? We're working with 2 and 5 again. but one of them is negative. Negative 2 times 5 is negative 10. Negative 2 plus 5 is 3. You can see that just 1x squared, right? 1x squared was already put in the first box. Negative 10 was filled into the last box. So that means we need to fill in negative 2 over here with an x and positive 5 with an x. Those came directly from the X game. Now we're ready to factor out GCFs. So let's do it. X squared and negative 2x, they share 1x in common. That is their greatest common factor. 5x and negative 10, they share a 5 in common. That is their greatest common factor. X squared and 5x share an x in common. That's their greatest common factor. And negative 2x and negative 10 share negative 2 as their greatest common factor. Always, always, always check your work. X times x is x squared. X times 5 is 5x. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. Once you've done that, we're ready to write it out in factored form, friends. But don't forget your GCF that we started out with. Remember how we had that GCF of 2 right here? You're going to pop that sucker right in front, okay? We're still going to write in the values from the outside of the box. X minus 2, x plus 5, because it's positive 5, and boom. 2x squared plus 6x minus 20 is the same as 2 times 1x squared plus 3x minus 10, which is the same as 2 times x minus 2 times x plus 5. Okay, hopefully you're starting to kind of put the pieces together, but I think the more examples we try truly, the more you're going to start to see the patterns. So just trust me on this one, and let's try another. What about negative 3x squared plus 13x plus 10? Let's start off with just like the regular questions. Is A negative right now? Yes, it is. So that means we're going to factor out a negative GCF, okay? Super important. We're going to factor out a negative GCF, right? And we see that I'm going to pull out a negative right now for the GCF, but I got to compare negative 3, 13, and 10. They don't share anything in common, so I'm just going to write negative 1. If I have a GCF, we need to extract it out and then rewrite our equation as 3x squared minus 13x minus 10, because we took out a negative. So that means A is 3, B is negative 13, C is negative 10. A times C goes at the top of my x, so negative 30 and positive 13 negative 13 goes at the bottom of my x. And so now I ask myself, what is two numbers that multiplies to negative 30 but adds up to negative 13? I'm talking about 10 and 3, but not positive. Ooh. No, actually, I don't think I'm going to use that at all. I'm going to use 15 and 2. It's so nice with this x. You catch yourself if you make a mistake. I know one number needs to be negative because I have negative 30. Negative 10 plus 3 was not going to give me negative 13. That's why I love the Xbox method so much. However, 15 and 2 multiplies to 30. Negative 15 times positive 2 is negative 30. That's what I need. And negative 15 plus 2, that's negative 13. Boom. Now here's our very first example where our box is empty. Okay, and typically our box is empty. And what we're going to do is we're going to put 3x squared here and negative 10 here. Then, based on our x, we're going to put negative 15x over here, 2x over here, and now we're ready to factor out the greatest common factor. 3x squared and 15x, they definitely share an x, and they also share 3, because 3 goes into 3 and 3 goes into 15. Then 2x and negative 10, they have a greatest common factor of 2. 3x squared and 2x, those guys share just an x. And negative 15x and negative 10, they're going to share a negative 5 as the greatest common factor. Always check your work. When they multiply, x times 3x is 3x squared. X times 2 is 2x. Negative 5 times 3x is 15x. Negative 5 times 2 is negative 10. You want to make sure you're keeping it real. Now remember, the GCF, pop that sucker in front, and now we're going to write our factored form based on what's outside of the box. X minus 5, 3x plus 2 because it's positive. So something to note, if there's a gap, it's positive or negative. Think about that number that you factored out. If it's a positive number, you'll put a plus sign. If it's a negative number, like negative 5, you'll have that minus sign there. Pretty cool. Let's do another together. Ooh, yeah, this one's a good one to do together. And then I'll have you finish the last two on your own. Okay, so negative 6x squared plus 8x minus 2. Is A negative? Yes. That means we're going to factor out at least a negative value, but let's see, negative 6, positive 8, and negative 2. Those all share a greatest common factor of 2. So I'm going to take that out right away and rewrite my expression. That's going to give me 3x squared. Think of it as like 6 divided by 2 gave me 3. 8 divided by 2 gives me 4. 2 divided by 2 gives me 1. That makes A 3, B 4, C 1. To fill in my x, I'm going to do A times C, or 3 times 1. I need numbers that multiply to 3, but add up to 4. This one's very nice. A number that multiplies to 3 but adds to 4? Guys, that's just 3 and 1. Absolutely. Let's go to our X box. We're going to start off with 3x squared from right here. And 1 goes in the last box. And based on our x, 3x, 1x. Now we're ready to take out the GCF. From here, they both share 3 and they both share x. From here, they both share 1. From here, they both share x. From here, they both share 1. Let's check our work. X times 3x is 3x squared. X times 1 is 1x. 1 times 3x is 3x. 1 times 1 is 1. Perfect. Don't forget, this GCF pops right out in front. Factored form is going to become x plus 1, because that's a positive 1. And 3x plus 1, because it's positive. Boom. The two green expressions are the same. Actually, all three of these are the same. But it made factoring nice and easy, going all the way down as far as we can. Cool. I hope you're starting Again, I'm not saying you're mastering. I hope you're starting to master how to factor using the Xbox method. So the next two examples are going to be you try, and the challenge, I'm going to ask you guys about this on Monday. So you can try it if you're feeling really, really good about this. But otherwise, I will see that on Monday with you guys. So I want you guys to stop the video, you try the last two, and you submit your notes with the you tries. You do not have to have anything submitted for the challenge unless you're up for it, okay? All right, guys. Have a great Friday. Have a good weekend. Don't forget to turn in your notes, and I'll see ya next time.